Hello everyone, this is Mr. Appel. Today we're going to talk about lines, segments, and rays. So first I want to review some notation that we've already talked about. When you're naming a line, for example, if I draw this line with points A and B on it, for example, we call the line that passes through those 2 points line AB, and we write that as AB with a line over it. Easy enough to remember. If we're interested in line segment AB, so if we're now just interested in the segment between A and B, not the whole line, we note that with that same AB, but now with a segment above it. Again, pretty easy to remember because it looks like what it is. And if we're interested in a ray that, for example, starts at point A and passes through point B, we would call that ray AB. And we're going to talk a little more about rays in just a second. But before we do that, there's some other notation, some other symbols I want to talk to you about. The one on the left here, I'm sure you're familiar with. That's the good old-fashioned equal sign. Equals, you know what that means. It means two things that are equal, that have the same value. Simple enough. You've been using that for a long time. This one over here, though, this symbol is probably new to you, and that is the symbol for congruent. And you notice they both look very similar. They have an equal sign, but congruent has this guy up here that makes it different. Congruent, the simplest way to remember it is congruent refers to shapes. So shapes can be congruent. So for example, this segment and this segment can be congruent. But you wouldn't say that those two segments are equal. However, if I knew that this segment was 5 inches long and this one was 5 inches long, you could say that 5 inches equals 5 inches. But you would never say 5 inches is congruent to 5 inches. It just doesn't make any sense. Never ever say that. So to summarize that, we could say shapes are congruent, numbers are equal. So shapes can be congruent, numbers can be equal. Kind of a subtle difference, but important to pay attention to that notation. So when you see this symbol, whoops, wrong tool. When you see this symbol here, you know what that means. Some more new notation to talk about. On the left, you've seen, we talked about this at the beginning, that bar over the AB means segment AB, or line segment AB. But over here on the right, this over here, the AB without the line over it, means something very specific. It means the measure of segment AB. So when it looks like this, without any symbol in front of it, without a bar over it, that means the measure of segment AB. So when you see that notation, make sure you pay attention. We're talking about the measure of it. So here I've drawn segment AB, and I see that it's labeled as being 5 inches long. So I could say that is segment AB, in which case I'd use this notation. But if I wanted to state its measure, I could say that AB is equal to 5 inches. So that means the measure of AB is equal to 5 inches. You would never, ever do this. You would never say segment AB is equal to 5 inches. That just doesn't make sense. So don't do that. Now let's talk about naming rays. Rays are a little tricky because they go in one direction. Looking at the figure I have here, if I'm interested in segment AB, for example, it's the segment that goes from point A to point B. It's that segment right there. So I could call that segment AB, I could call it segment BA, doesn't matter. But when you say, for example, ray AB, that means something different. It means the ray that starts at A and passes through B. So I'm drawing it above so that we can see it. It starts at A and passes through B. That is different from ray BA that starts at B and passes through A. Those are two different rays. So with rays, the order that you name them is important. So be really careful with that. So this you're definitely going to want to write down. These are called opposite rays. This is a new term you're probably not familiar with. Opposite rays opposite rays, are rays that share an endpoint and go in opposite directions. So it's not just that they go in opposite directions, it's that they start, in this example, you see that they start at point A, so one ray goes from A and passes through B, and then the other ray starts at A and passes through C. They go in the opposite direction, but they start at the same point. You would not, however, say that, for example, ray BA and ray CA are opposite rays. Yes, they're going in opposite directions, but they don't start at the same place, so those are not opposite rays. Now I want to show you an example of solving a problem involving algebra and line segments. So the segment addition postulate, which we'll get into more as we go along, but basically says what you probably already know, which is if you have a segment like in this figure, that if you look at AB, which in this case is we're told it's 2x minus 3, and you look at BC, this segment here, that those two small pieces, this one and this one, add up to the whole long segment. Kind of obvious, but really important so that we can solve problems. So it's safe to say that the measure of AB, remember that notation means the measure of AB, plus the measure of BC is going to be equal to the measure of AC. And we know that because of the segment addition postulate. Once we know that, we can go ahead and plug in our values, 2x minus 3 for AB, 3x minus 12 for BC, and 60, which is hiding up there at the beginning, for AC. And then we'll have a problem we can solve. So 2x minus 3 plus 3x minus 12 equals 60. Let's combine our like terms together, get our algebra on. 5x minus 15 equals 60. Add the 15 to both sides. We get 5x equals 75. Divide by 5, and we get x equals 15. Now we've got to make sure we've actually answered the question. We found the value of x, that was part 1, but we also have to find the measure of AB and the measure of BC. So, AB is 2x minus 3, so that's 2 times 15, which is 30, minus 3 is 27. And BC, the measure of BC, notice I always read that, the measure of BC is 3 times 15, which is 45, minus 12, which is 33. And I can check my work to make sure that those two do in fact add up to 60, which is what I'm expecting, and sure enough, they do add up to 60. AB here is 27, BC is 33, they add up to 60, so it looks like I did it right. Okay, thanks for watching. Now I want you to go back on Schoology and try the lines, segments, and rays practice problems.